A member in a derived class can redefine a member in its base class. This can be done for all kinds of inherited members, but it is most often used to give instance methods new implementations. To give a method a new implementation, the method is redefined in the child class, with the same signature as it has in the base class. The signature includes the name, parameters, and return type of the method. It must be specified whether the method is intended to hide or override the inherited method. By default, the new method will hide it, but the compiler will give a warning that the behavior should be explicitly specified. To remove the warning, the new modifier needs to be used. This specifies that the intention was to hide the inherited method and to replace it with a new implementation. Before a method can be overridden, the virtual modifier must first be added to the method in the base class. This modifier allows the method to be overridden in a derived class. The override modifier can then be used to change the implementation of the inherited method. The difference between override and new is shown when a square is upcast to a rectangle. If the method is redefined with the new modifier, then this allows access to the previously hidden method defined in rectangle. On the other hand, if the method is redefined using the override modifier, then the upcast will still call the version defined in square. Basically, the new modifier redefines the method down the class hierarchy, while override redefines the method both up and down in the hierarchy. To stop an overridden method from being further overridden in classes that inherit from the derived class, the method can be declared as sealed to negate the virtual modifier. A class can also be declared as sealed to prevent any class from inheriting it. There is a way to access a parent's method even if it has been redefined. This is done by using the base keyword to reference the base class instance. Whether the method is hidden or overridden, it can still be reached by using this keyword. The base keyword can also be used to call a base class constructor from a derived class constructor. The keyword is then used as a method call before the constructor's body, prefixed by a colon. When a derived class constructor does not have an explicit call to the base class constructor, the compiler will automatically insert a call to the parameterless base class constructor, in order to ensure that the base class is properly constructed. Note that if the base class has a constructor defined that is not parameterless, the compiler will not create a default parameterless constructor. Therefore, defining a constructor in the derived class, without an explicit call to a defined base class constructor, will cause a compiled time error.